Okay, hello. As was mentioned, my name is Konrad Jakubiec, and today I would like you to take you on a journey to my domain which is very time specific, where business speaks with some defined, precise timeframes when these timestamps are well named. Also, I would like to build some understandings what the time-based domain events are in terms of domain-driven design also, and how we can leverage Kafka, for example, as a solution to build it, comparing to other ways how we can achieve such solution. I have been working at VirtusLab for almost 3 years. I am not only a leader of a domain-driven design guild at this company, but also of my own team, which is focused for building some reactive microservices with some event-driven architecture. I spend my free time playing drums, so you can meet me not only on an IT conference, but maybe also on some gig. My presentation is divided into a couple of parts. Firstly, I would like to give you some context, so explain a little bit about my domain, my business, also maybe a little bit about my client, giving some real case scenarios. And this is because we would like to discover what the time-based domain events are, and then jump to another concept which occurred during the gathering some requirements which are just-in-time events. Then, having this in mind, there will be implementation which enable us to just deliver this kind of approach. Of course, as a summary, I would like to share some takeaways, what we did, what went wrong, what are some interesting facts about this implementation, and at the end, I would like to share some handful references which help me to not only build this software but also to prepare this content. I would be grateful if you can ask your question at the end of your presentation. So let's jump to the first topic, so the employee experience expertise. Our client is a big UK retailer, and my domain is very employee specific. Employee experience is a bunch of techniques, methodologies, and software which helps engage with employee. One of them is rewards and benefits, and this is what is my main interest. This is my context within. There are some eligibility criteria, some rules, how particular benefits can be delivered, can be assigned to employees. And you can imagine that it won't be able if we don't have information about this employee. So in this relation, there is another context, which is employee work cycle context. This is upstream, downstream dependency. So in my case, I am just a dependent part to anything which happens in the employee work cycle context. Speaking about events, maybe you've already known that there is some concept called domain events. They are represented as those orange blocks, for example, employee joined and discount associated. Domain events are facts in the past which people take care of. They are important for a business, and well, it's crucial to remember they already happened. To build any kind of this kind of relation, which is event-driven, there must be some streaming between those two contexts, which of course then I will elaborate on how we can build it. Let's focus about the first case. Our domain expert said that after 6 months of service, discount becomes effective. That's cool. Discount is a kind of our benefit. We know that when it should be effective for a given employee, and there is some time involved. We've already gathered that events are something which already happened in the past. This time we have a notion of time, the 6 months of service. So I did a research, what is available on the market to just do such implementation based on a time. Unfortunately, there is a niche of time-based domain events. Looking at some interesting articles, I found Mr. Kevin Weber, which states that schedulers and timers are also very interesting types of events, but they are often timed as an implementation level consideration. So implementation details, you shouldn't take much for it, right? The other important persona, Mr. Veron, says that expiring timeframe will generally have a descriptive name that will become part of your ubiquitous language. That's better, because we are trying to move from this implementation details to something which is explicitly named. And he adds, therefore you have a name for that particular time-based domain event. Cool, it suits my case. So you can imagine that for this scenario, that this after 6 months of service, and there will be an evil discount became effective. So something which happened in the past because of time. But, well, the question is, what is this expiring time frame in that context? And asking our product manager, domain expert, who already was annoyed with our questions, he stated that when eligibility date is reached, then discount becomes effective. So here we can talk about some kind of policy, which is called discount eligibility date, and it takes 6 months to trigger any event. To recap this one, I would like to focus that there is an emphasis put on the expiring time frame, which is precise point in time in this context from a 6 months of service. It's relevant for our ubiquitous language because our domain expert stated this particular name, and we can just reflect it. It's well named, but on the other hand, it's niche, it's quite uncommon, and at the end, well, implementation details, right? Having this in mind, let's take a look at the other example. Just-in-time events. This time we would like to model towards the time-based domain events at all. And there will be some controversial approach because, well, we will introduce event scheduler. And you may ask, well, but events are about something in the past, so why we need to schedule them? Let's take a look at another scenario, leavers. Whenever an employee leaves, an effective discount should be disassociated. And the side note, if you're familiar with event storming, the color on the stickers are just I tried to follow the official notation. So this flow can look like from the left to the right, that on an employee left event, we have action to disassociate discount. And if it's effective, then this is some our aggregate, which takes care about our consistent state. Another event will be published. So simple, from the left to the right. But here are some dragons hidden. So unfortunately, employee work cycle context doesn't publish such event. It's older application, it's very historical one, and it's more like the HR people marking employees as leavers whenever they decided to leave a company. So in this way, they publish employee mark as leaver event, which has the leaving date inside. This date can be in the past or in the future. So it's not quite useful from our use case. There is one pattern introduced by Martin Fowler called Retroactive event. It's about how we can compensate state or apply some changes which have date at ease and which applies to the future or to the past. But it sounds kind of fuzzy, similar like this book, which is also about retroactive events, but the whole title is so long that we just didn't go that path. So what can we do? We can build anti-corruption layer. So a layer where in between employee mark as leaver event will be some block which will translate it to employee left event. to just leverage the simple left to the right flow, which I showed you at the beginning. The idea is to build, well, the event scheduler. So something which will allow us to schedule an event, so just postpone it, and then translate and also publish to the dedicated context whenever we achieve this time, when this time become effective. Speaking about event streaming, there is a Kafka between those two contexts because for a simplicity, Redis states that both contexts are separated services and there is a Kafka in between them. And okay, let's just focus on some drivers for this kind of solution. We take care about days. Our precision is about days, so no matter when, if employee leaves in the morning or in the afternoon, if it's still the same day, then that's okay. Our company consists of 450,000 employees, and circa there is 9,000 leavers per month. We also take care about some isolation processing because we would like to have just a singular thread application taking care about singular employee. It's quite important. And we are forced to use existing infrastructure because we begged our architects or whatever that we would like to use Kafka, so now we are not allowed to add additional piece of infrastructure, we'll just deal with it. And of course, we would like to have a fault tolerance to not lose any events and to not lose notification that employee left. And there are some discounts still active for particular employees. And at the end, we would like to have some, we don't want to have the duplication of events. Here I would like to talk about Kafka Streams. How many of you have used Kafka at production? Cool. So very quickly, Kafka Streams is a library built on the basic concept of Kafka itself, so the consumer producers, topics and partitions. They are like an application which can have multiple streaming threads, but the very crucial thing is that there is a guarantee that the partition will be processed only by one thread. Inside the application, there is some topology of particular processors which can share state, and by streaming, multiple operations can be applied, like mapping, grouping, or aggregation. This is the power of Kafka Streams. For example, Kafka provides some DSL, which enables us to just build some interesting streaming pipeline where we can group employees, aggregate them, and so on. And so how we can use it to postpone event publishing? We have two topics, employee events topic and effective events topic. And this middle part, which will postpone event publishing. So how to achieve something like this? That on the one side, there is employee mark as leaver, and on the other side is employee left event. And some magic that we will schedule an event, wait some time, and publish it again to another topic. This is the idea. Fortunately, Kafka DSL is built on some other abstraction, which is called Kafka Streams Processor API. This is the main interface of the processor API, and you can already may spot it that there is a scheduler, because we can invoke schedule on a context which consists of duration, punctuation, and some callback which we invoked whenever schedule happened. Okay, and here we should talk a little bit about the processor time, so how Kafka deals with time, because it's quite important from that perspective. There are two notions, the stream time, which is a time when, this time is calculated whenever new messages appears on a Kafka. And the time is a time between the of them based on the timestamp assigned to this particular records. So we move time only when new events appears on the Kafka. The other thing is workload time. Workload time is just a usual clocking timer, like on my hand, that, for example, every 10 seconds do something. However, there is a nitty-gritty details about it. In the documentation, it is stated that this is best effort, and because there is a guarantee that all nodes in a topology will just process it in a one thread, and only when this processing ends, then the callback on a schedule will happen, even though if the schedule interval is longer. And the other thing is the settings about how often Kafka Stream application will poll events from a topic, because there might be some overlapping between those two times, the schedule time and the interval of polling. So remind this. Okay, the other question: where put not effective events? Because, well, in the usual case, when you decide to leave company, for example, you have 2 months period to still work on that company. So we need to wait those 2 months for somehow. As I mentioned, there's a concept of state stores in Kafka, and we can choose values of them in memory or persistence, and they are backed with RocksDB. This is additional library which is also provided by Kafka. It's also external product. RocksDB mostly works as an in-memory cache, but there is a way to persist data on a disk to flash them. And whenever there is a commit of offset while processing messages on the Kafka, it also flashes the content of a persistent RocksDB store to the disk. The another interesting, I would say, very helpful thing about the RocksDB is replicated to the internal Kafka topic. So even if we lose the in-memory topic, it will be recreated using internal topic from Kafka. So in case of failure, there's a way to have a last state, but of course, it will take some time. So is it still feasible, having this in mind, to achieve this? Let's talk about some ideas. We can build a Kafka Stream application, use state store to store not effective events, schedule some punctuation to poll for effective events from state stored, and forward them. It doesn't look so hard. So the topology may look like this. We will read events from employee events topic, translate them, schedule, which is some state store, and forward them back to dedicated topic. So right now I'm going to show you some code, which is just a proof of concept of this idea. And it's written in Kotlin, so just don't blame me. So let's start with the first one. It's a translator, and I know that this is the anti-pattern to have just the when statement with only one condition, but I left it here purposely because we'll extend it later. Here we are just translating employee Marcus leaver into the expected event, which is employee left. And then we will forward it to the dedicated child node. I think the other one in topology is about the scheduler. Here we will use the effective events store to put the event to future processing. Let's talk a little bit about the keys. The key starts with effective date, followed by employee ID or event ID, and event type. So it's worth to remember that it starts with a date, which is just a string. And this is this callback here, which invokes the schedule. Right now, something went wrong. Another one in the topology is effective event forwarder. Here we are going to use this schedule mechanism. And as a callback, we will forward the effective event and just commit it. So For forwarding, we are just iterating over all effective events and use another callback to forward them. And by effective events iteration, I mean that on this effective event store, which is mapped as a date, employee ID, event type to the value of particular event, we'll use something which API of this state store provides us, which is the range query. And this is interesting part of this implementation because we use a 0 as a string and the tomorrow date. Why it would work, possibly. And this is another nitty-gritty detail because when you use persistent state store, which is backed with RocksDB, it performs lexicographical comparison of all records in that state store. This is why whenever you compare something to 0, like today's day, it will be greater, and we choose tomorrow as the end of the query, and it ignores the rest. And then we will just forward it. So maybe some test scenarios. Okay, sorry. So here we just try to prove that it worked. There is a nice test driver for Kafka Stream application, which allows us to test all of these interesting details, like also advancing a time and creating some topic for test. It's kind of cool. So also it's worth abstracting a time, because if you deal with time, you would like to have a control within the code base. For example, set that today dates will change to some future date to check another criteria. Here we are just ensuring that no additional events will be forwarded to not have duplicates. So does it work with this shape? Almost, because, well, bearing in mind this range query and this setting, we querying for particular range. We forward effective events. However, if we have some duration, some schedule, for example, every each hour, we still have the same results from that query in the state store. So it will result in duplicates forwarded to additional to the topic. So just let's introduce a cleaner. Just another node in the topology, which will just delete already effective events from this state store. And the end topology looks like this. Here is an effective event stored. Here's effective events. And we read effective events from an output topic. We do it to ensure that effective events will be cleaned only when they are already appeared on the output topic. So you may ask, are we done? Not really, because in a real scenario, well, you are a crucial person in a project, and you are convinced to, well, let's stay another month in a project. So you will just postpone till leaving. How we can deal with it with this approach? And the idea is similar. We just would like to extend translator to forward reschedule command instead of schedule whenever there is a leaving postponed event on the one end. Add a new state to store event key to effective date mapping. It is important because we would like to know the previous effective date to delete it and to not schedule previous event. We also need to extend scheduler to use this new store, add new processor, which will take care of rescheduling, and of course extend cleaner with another state store to clean up. For this time, topology looks like this. It's kind of messy. By the way, there is an online tool to just draw these diagrams based on the output of your topology.describe method. And here you can see there is another state store, another node which is tied to the translator, which decides if the event should be scheduled or rescheduled. Okay, so here when it comes to the reschedule implementation, we have the another state start used where the key is employee ID and event type and the value is the actual effective date. So having this in mind, the reschedule will iterate over effective dates for particular event if there is any, because well, we may got some out of order events and something may went wrong and we need to ensure that we have something to change. So in this case, if there is this effective event, we will perform this callback, which is about deleting the current effective date, putting a new one, putting a new event, and then putting a new effective date. Okay, that's cool. What next? Okay, another thing which is kind of also quite common in our projects is that, well, I got my salary doubled, so maybe I will stay in that company and I don't want to leave a company any longer, so I would like to cancel my leaving from that company. In this case, we can follow the same approach, yet another processor, canceller this time. The only thing which is with this processor is responsible for is just the addition of from both stores the already scheduled event and the date which is mapped to the particular key. So the final topology looks like this. There is this one additional bit, and also this is output of a translator. So we achieved a couple of things here with this approach. The goal was to do it on Kafka, and it was done. It occurred that the Kafka Streams topology together with test driver and the incremental approach is quite of composable things, and we can also visualize it over the topologies. It's quite cool idea. There is a good bit of testability when it comes to the Kafka Stream application. You can just test it end to end, and because this is what you take care in this approach, that something is on the input topic and you expect something else on the output topic, on specific time, of course, for this context. There is an out-of-the-box KBit based on Kafka partitioning. As you probably know, Kafka uses topics which are divided into partition, well, which you need to decide amount of them probably at the beginning of the project. But still, you can leverage from it, and you have achieved quite cool of level of parallelism using the partitioning here. And also, it guarantees that only one thread, let's say application, will be responsible for a given partition at time. So no race conditions. Because of state stores are replicated to internal topics and they are also flashed to disk, there is a good extent of fault tolerancy. So this is another goal which we achieved. And because of also partition, there is an isolation of processing, what was already mentioned. However, I think there is a lot of consideration with this approach. First of all, usage of low-level processor API. There's a nice, composable, builder-like, fluent API, Kafka Streams DSL, which possibly could have been used, but it still doesn't have the capabilities to support this particular scenario. The other thing is, well, we use two state stores which are shared between processors, which are accessed from a context. It smells. Whenever you share a state, it smells. Of course, there is this guarantee that within one Kafka Stream application, you will have this guarantee that nobody else will touch this state store. We use a range query, which is based on some internals, right? The internals of RocksDB, which use lexicographical comparison, and this is also not perfect in this scenario. Because there is no time to live in state stores, we need to clean them up manually. for example, when you come to the topics, you can set up some retention policy, which doesn't apply to state stores. Because of the usage of RocksDB and committing it very frequently, so flashing to disk, there is an increased resource usage, both memory and disk, because we decided to just flash the content to disk whenever we successfully forward events to the output topic. Another one is this interesting bit about wall clock time, which is stated as best effort approach because of the polling of Kafka Streams application for new events. So they may overlap, and well, it's just a best effort that it may not occur precisely, let's say, every 1 hour, but when, for example, 1 hour and a couple of minutes. In our case, it's not a big deal because we take care about days. So some takeaways at the end. Read documentation. I really recommend it. Even if it's full, sometimes it's full of some business claims that we can achieve that or another thing, still it provides you a lot of information how internals works. I wouldn't have known, for example, about this best guarantee of work clock time without the documentation. And because of documentation and adjust different configuration, because sometimes it may suit you, and then you get just alert on the production because you didn't change some value which was default. It's worth to remember. Measure things, in this case, performance and resource usage. As I mentioned, RocksDB can consume a lot of memory, and if you run on containers and there is a specific or a Kubernetes and you set some required resources, it may be not enough, and you are not even aware why it's not enough for this case. Good advice is to abstract time. If you deal with time in your code base, it's a good idea to have some common abstraction to just deal with time, to control it in test, or just based on particular one implementation, not worrying that if you need to use a local date, the zone date, and so on. And at the end, is it a really suitable solution for scheduling? You may ask. I was still asking myself about this. But taking a look at alternatives, recently Kafka introduced suppress operator. It sounded promising, but it's more for windowed operation, and it's only based on a stream time. So it's not possible to have it, for example, every 1 hour, but whenever a new event comes to your topic. And the main purpose of it is to emitting only a final result of some windowed aggregation, not waiting or postponed publishing the event for a specific time. Another thing which we found is a Redis, because Redis has this notion of notifications. Whenever, for example, whenever the event expires, so we achieve some TTL. However, it is precisely and explicitly stated in the documentation that Redis server deletes the key and not when the time to leave thread actually reaches the value of 0. So there are also some trade-offs, and also the PubSub model in Redis is just a fire and forget. So there are not so strong guarantees. The other thing, which is more, I would say, stronger guarantees when it comes to persistency, is just polling some persistent data store like database. It's, I think, quite common idea. Just store this event in the database, have a Quartz or schedule Lambda or schedule Kubernetes jobs, whatever, and poll for events. That's cool if you don't have them too many, because it's harder to scale it. Then if you would like to just scale it, you need to have partitioning, sharding, and additional bits to maintain it. So this is some trade-offs. And slowly I'm just going to my very end slide, couple of references, there's a code base. This one is about the very, Kafka has its own Confluence site, which describes all of the decisions which they are took to build some things, for example, like state stores. And I really recommend to read that articles because they explain a lot when it comes to Kafka. There is some reference to retroactive event, not this book, but mainly to Martin Fowler. The blog from Kevin Weber about what can be done beyond the Kafka DSL, so how processor API works. Some internal data management in Kafka, as I mentioned, also on Kafka Confluence articles. A couple of another, and the last one is a Kafka topology visualization tool. So it brings me to the end of my presentation. And if you have any questions, I would love to answer them. Thank you.